I wanted to talk about scaling Lightning using LND. I started working at Lightning Labs 3 years ago, and we've come really a long way. I started working with LND before that when I worked at BitGo, and that was kind of like, the barest, the almost didn't work. It was crashing every day type of a scenario. And now we're 3 years later, we're trying to scale this to millions of people. We're trying to scale this to millions of payments. And I kind of wanted to cover, like, how do we do that? How do we do that with the software, with LND software? So a lot of people kind of like throw out scaling as like, how do we scale LND? And a lot of the answer to that depends on like, how do you even define what scaling is? So like, I want to scale maybe the amount that I put on my node. So sometimes people coming up to ask me, like, I have my Raspberry Pi and I put on, $1,000 on there, but now I want to, now I'm comfortable with it. I want to go up to $10,000 or, $100,000, but how do I scale that volume? I'm afraid like something's going to happen to that Raspberry Pi. And then there's availability, like the same thing with the Raspberry Pi nodes. Maybe my internet cuts out, I have a storm or something. Like, how do I scale, like, to make sure that I have super high uptime? Then there's like latency, how quickly can I make a payment across the network? And there's decentralization. There's all sorts of different aspects to scale, is what I'm saying. So like, my philosophy on how to scale Lightning might not be the same as everybody else's, but kind of like the perspective that LND has, and that I think is a good perspective, is that you don't necessarily need to be a routing node yourself. And that's kind of like always been our design idea, is that a routing node is a specialist operation that, we hope people at all levels partake in, but it requires somebody who actually wants to do something like that. And that means that it wouldn't be the mobile wallet user, and it wouldn't be the merchant, and it wouldn't be the exchange. It would be somebody, although it could be all those people, we don't want to make it so that that's like a necessity, that's a requirement for them. We want to have specialization. We want to say that a routing node is somebody who has one job. Their job is kind of like the ISP. Their job is to connect you with other people. And if they don't do that, they're not going to get paid. But despite this, a lot of people who are running on the Lightning Network and scaling up, they're basically trying to run routing nodes and not doing a good job of it. And that applies also even to if you're not a major player in the Lightning Network and you want to figure out who to connect to. It's not necessarily a great idea to connect to somebody who is a well-known merchant or a well-known exchange, because in all likelihood, they're spending their time managing their exchange or managing their store. They're not spending their time managing their node specifically. So there's a huge variance, and there's plenty of big nodes that do a terrible job of being a routing node. But the interesting thing about routing nodes is that they need other routing nodes. So what we want to have is like this big connected network where I can connect to a routing node, and that's going to multiply the utility of my funds. Because if I just had my funds in a peer-to-peer channel with the person that I'm paying, the utility of those funds is very limited. It's like a gift card at one shop that you can only pay for at that shop. What we want is for the funds that you have on Lightning to be as good as cash. You can use them at any store. And for that to happen, you need to connect to somebody who's networked who's connected to other people who are connected to other people, and all one giant mass of people who are all connected to each other. So routing nodes, you need a routing node in order to connect your payments to other people, and routing nodes themselves need connectivity outside of that. So that's kind of like a big concept of what a routing node is. Okay, like I said, I'm telling people don't do routing nodes. You're a merchant, find routing nodes that can be useful to you. or you're an exchange, find routing nodes, or you're just buying stuff, find other people to do routing nodes, and people don't like to listen to that. They like to run their own routing nodes. So I think that's cool, like if you want to try it. So I think like the way to think about how to run the routing node is kind of specific to itself. Like, there's like it's a whole game. It's a whole like strategy system into itself. And one thing that I think a lot of people make as a mistake is that they create the routing node and they look at other nodes that have a million billion connections, and they're like, those are the best nodes. Or they think about their own node and they're like, okay, I have 1 Bitcoin and the minimum channel size is 20,000 Satoshis. So I'll just make as many channels as I possibly can to everybody, and that way I'll have the best chance of connecting other people together. And then the graph algorithm will think that I'm amazing because I'm connecting a bajillion people. And I think that's a bad strategy because the main limitation in Lightning is capital. You can't move capital through the channels unless you've committed it. So these 20,000 Satoshi channels are kind of worthless. So I kind of think of a good number as like, there's like this theory of the Dunbar number of like how many people can you even keep in your head of like who you even know, who you're interacting with. And I think that also applies to the like 6 degrees of separation concept of Lightning. So like Lightning, the idea of it is if you just have the people that you know, and you want to connect with some random person anywhere on the earth, you can ask one of the people that you know, do they know a person that they know that knows a person that they know? And because we have exponential growth, it doesn't like you'll be able to connect with them even if people just have normal numbers of people that they know. So I think the same thing applies to Lightning. No matter how big the network grows, if you just have a normal set of people that you're kind of connected to, you'll be able to pay to anybody in the world. The other thing I'd say about a routing node of how to run it is that you need to be continuously improving. I think I kind of think about it like you're an animal. An animal, if you just dropped it in the forest or something, it's going to have reaction to stimuli. That's how it's alive. And sometimes people put up a node, and then no matter what happens, it doesn't matter. They've forgotten about managing it. They're not looking at it. And what happens is it basically just dies. It's not earning any routing fees because it's not reacting to its environment. But what you should be doing is you should be saying, money's flowing over here, so I'm going to move capital over here. You should be saying, nothing is happening over here, I'm going to remove capital from here. And if you're doing rebalancing, you should be saying, okay, rebalancing needs to happen over here because when I do it, something good happens. Or if you're doing fee changes, you could be saying, if I increase the fee, then my traffic goes away, and that's bad because I want traffic to happen. So that's kind of the job in a nutshell of what managing the routing node means. The other thing about running a routing node is that there's a lot of different access patterns of how traffic is flowing, and it's important to know that. And that's also why I get back to the Dunbar number. You can only really keep a certain number, especially if you're doing manual management of your routing node. You're only going to be able to keep a certain number of node identities in your mind at one time. So one thing I do is I do categorization of my nodes. I'm this node is this type of node, and this node is another type of node, and then I can kind of know what type of actions to deal with them. Another thing that I notice is that even people who are experts on routing and are telling people here's how routing should work, or here's some algorithm, they're not paying attention to one of the most basic ideas of routing, which is that in order to forward a payment, you need to have local balance on your channel. And if you don't, what will happen is the person will go to try to pay, and they won't know that you don't have local balance, and you will return to them temporary channel failure. and you'll say, I don't have balance right now. So if you tried to go and make payments arbitrarily in the network right now, you would go to all sorts of different nodes, and the nodes wouldn't have local balance on their channels, and they would all start to return errors that would say temporary channel failure, temporary channel failure, and that'll be very exacerbated if you try to send a big payment because people aren't, keeping big balances on their channels in corresponding to where the money wants to go. So that's part of the job of running the routing node. The other thing I think people don't really recognize is that running a routing node actually consumes disk space. And what I notice is that people who run it, they just ignore that they have this disk that's filling up. They ignore that this database is getting bigger and bigger and bigger. And that's something that you also have as a job, especially just like in the present day of like what the tooling we have right now. And especially if you install automation. Every time you actually make a payment, even if the payment fails, you are accumulating state in your database. And LND, there's a lot we can do to even reduce that state, but at the core, like every time you make a new channel state with your peer, you're adding more data that you have to keep around. So if you automate something, you might be tempted to say like, I'll just make a script and like every 30 seconds I'm going to try to make a payment. But actually that does have a cost to you. And you might not even realize it, but you'll wake up one day and you'll say, well, my database is full because I tried this every 30-second thing and I wasn't doing anything. And I just filled up my whole channel state with garbage. So I think like what we have today, if we're here 3 or 4 years in, I think 3 or 4 years in the future, it'll be totally different. And one thing I think it'll be more like is there'll be more virtualization of what a node is. Because a node, it's kind of two things, like it's kind of like a database and also like a set of keys. And you could run that on many different servers. And they could all kind of like work together with each other. But currently LND isn't set up for that. But it's something that we can expand on in the future. And you could say like, actually my node is lots of different servers. It's not a one-to-one mapping. Okay, so routing node had a lot of info on that subject because I like to run routing nodes. And I think it's interesting. But like, there's also people who come to me and they're like, we want to receive tons and tons of payments on Lightning. And we've done tests where we go through the whole flow of creating invoices. And, what is an invoice is actually kind of like creating an invoice is pegging the database because every invoice is creating this new record in the database. It has to lock it. So when we want to create it, when we had a flood of customers who come in and they want to create a million invoices, then we have a queue, we have a wait time, we have errors. And this is especially apparent when your routing node is the same as your invoicing node. So my basic recommendation for people who are trying to scale the easy way is horizontally scale with multiple private nodes. Because you don't really have to implement anything super special. You're running the same thing that everybody else is running. And if you need to make more invoices, just make more little private nodes that have connections to routing nodes. And it's very simple. And if you can cycle them out because invoices aren't long-lived. So you can say, okay, I'm going to make invoices on this node, and there's a bunch of new customers. They've come in and they're flooding me with new invoice requests. So I'll just spin up a bunch of my private nodes and have them all take jobs off of that invoice queue. And then if the invoice burst goes away, I can spin down those nodes. And I don't need, that's something you can't do if you run the routing node. If you run a routing node, you can't just like say, oh, I'm going to create a new routing node out of thin air. So it's just easier and more self-contained if you have these private nodes. The other thing I think, like as far as like value scaling, if you're a merchant and you're generating tons and tons of inbound revenue, you're creating like a problem for yourself that you might not even realize, which is when you receive a payment, the payment payer is using up like the easiest, cheapest liquidity that they can to get to you. And so if you have payer one, they're going to use the easiest, cheapest path to get you to you. And then payer two, they maybe don't have access to that path. So they'll try the first path and they'll get the temporary channel failure maybe. and then they'll have to go to path 2. And they'll say, okay, I found it after path 1, didn't have to wait too long, path 2. But if you have millions of customers and they're all coming in, payer 1 payer 1 million is now having to go to path 1, 2, 3, 4, all through a million to figure out how to get to you. And it's becoming progressively harder to pay you, progressively more expensive to pay you. And you might not even realize it because you don't see the payer having these struggles. All you see is the invoice is not getting paid. Why is it not getting paid? And a lot of times people are scaling and they're hitting this problem and they're not even seeing it. So the solution is that if you are very heavily inbound, you need to be pushing the funds out back to the network. So number one way is pay your suppliers with Lightning. So pay your employees with Lightning. Pay the people who are, anybody you can with Lightning, because every time, if you're receiving a lot, every time you make a payment, you're actually making room for a future payment back to you. But we also, at Lightning Labs, we have a service called Lightning Loop, where you can pay to us off the chain, and then we will pay you back on chain in a non-custodial swap. So that's a pretty popular service. And it also has the advantage that if you're a merchant and you're receiving millions of dollars and you aren't making payments, you don't need to keep those on your hot wallet. You can remove them and put them in you can loop them out, push them off to the cold storage. And then you don't have to worry about like, okay, I'm securing too much money, or what if there's something that hacked? You can kind of keep your security under control by like maybe every day or every week pushing out the funds that you've received back to the chain, back to an exchange, that kind of thing. So like if I were to get more complicated about how to scale LND invoicing, I would actually like go back to what an invoice even means. And what an invoice is two things. One is it's a secret, it's a pre-image of a Lightning payment. And the other thing is it's a database metadata about what the payment is for, like how long until it expires, like what is it associated with. So usually the scaling problem when it comes to creating a lot of invoices is the metadata actually, because you have to be inserting all these rows. The secret generation part is very simple because all you're doing is just creating a cryptographic random 32-byte number. So one way that we could actually, if you wanted to kind of like end game scale it, would be that you would separate these two processes out, and actually you wouldn't even use LND to create your invoice. Instead, what you'd do is you'd use LND's API called the HTLC interceptor, which allows you to interactively interact with the forwards that your node is getting. And so what you would do is you would say, maybe I have a bunch of virtual channels that I just made up channel IDs for, and I pretend that they're private channels that actually exist, but they don't exist. And instead, what they are, they're just representing like a shared secret that I have between all my different nodes. And whenever any forward that I see comes in and it matches a hash, a pre-image that I've already created, and I created bajillions of them, in memory somewhere, then I can fast settle it. I can pretend like the end node received it, but even though it didn't. And because I've created like these virtual channels, I didn't even need to make channels, and I didn't even need to receive it on the node that it came in. I can say like I have like an array of 5 different nodes, whichever node that the payer pays into. I have the pre-image and I can take it right there. And the database, you can use any type of database you want, because that's all you're doing is kind of checking the metadata, like is the expiry up, that kind of thing. So with that kind of architecture, you'd be able to accept payments at the rate which will be limited by the forwarding. So as fast as you could forward, you would be able to receive payments. And that would be the natural limit also, even without your control, because other people are having to forward to you. So they would also be the bottleneck on you, like the greater network would be. Okay. Receiving payments is actually a lot easier to scale than making payments. So sometimes we have customers who come to us and they're like, I want to get ready to be able to pay in, super rapid succession 1,000 invoices, or maybe I have a big website and all the users are going to be wanting to stream payments and listen to podcasts and stuff all at the same time. And we've done some calculations on the current payment speed of LND, or we're doing some tests, and we're like, there's a limit of how much that one node is going to be able to support in terms of payments. So like LND currently, just to calculate one route on my node, it takes probably 1 or 2 seconds. So that means if I had a bunch of users, I wouldn't be able to make very many payments at all. And that's just pathfinding. That's not actually even making the payment. Making the payment, it can take minutes to make a payment, and you are maybe using some liquidity while you make the payment. While you search for it, you're locking some capital along the routes. So it can be tricky to scale up payments, but I would recommend even using the same concept that I recommended before, where you would make many different little private nodes, and that you would connect them independently. And then as you needed to make more payments, you would add more private nodes. And then in LND 0.14, like our next release, we're going to also be moving the payment graph into memory, which will have a big speed up in terms of the pathfinding time. So I would say, there'd be at least a 10x speed up in terms of one node can handle 10 times as many payments just in terms of calculations. And then if you needed to scale, it'd be still pretty simple. You would be spinning up nodes, and each one of those nodes would be kind of independently paying, and you could scale it up or down as you wanted to. And you wouldn't want to do that with the routing node because you would run into that limitation. So and the payments also have the database problem, but way worse than invoices in LND, because in LND currently, when you make a payment, every single attempt that you make, even if it fails, is stored in the database. So the database kind of has this log of all the different information about that you've learned when you made the payment, it's a major cause of the nodes to slow down. So like if you're running a lot of payments on your routing node and you notice that the performance is slipping, probably what's happening is your database is filling up with all this payment data. That's also something that we're working on in LND 0.14. We're going to allow you to remove the payment data that failed, that wasn't interesting to you. And currently, like the way that I scale now without that feature is I actually delete all my payments every week or so from my node. And that's kind of a common scaling practice, is that people are going to their node and removing every single payment record, because that's the API that's currently available to LND as far as how you can manipulate your payment history data. And then, like I said, every time you're updating the state of a channel, every time you're doing a forward, you're creating disk records. So that's another way to reduce the size of your database in relation to payments, is that you can take a look at the number of updates on a channel, the number of past states that existed, and if it gets too high and the mempool is pretty low, you can close the channel and then reopen the channel, and you can kind of reclaim some of the disk space because it doesn't need to keep around old states that don't exist anymore. The thing that people say might not work or are worried about working is that they think that the pathfinding won't succeed. But actually, I think that's usually related to people's routing settings, and that's something that we also have been improving in LND so far. But it's something that people don't maybe know about as how to manipulate their nodes. And in LND, what it has is it has this router RPC settings in the LND.conf. And pathfinding is a trade-off between different variables. It's not like pathfinding can just improve by itself. You can say that your pathfinding can get the most naive pathfinding algorithm would be, I'll calculate every single possible route that I can make it through the network, and then I'll sort all the routes by which one is the cheapest route. And then I'll try cheap 1, cheap 2, cheap 3, cheap 4, and eventually I'll arrive at the cheapest route, and I'll be happy that my payment didn't take too much money. But if you actually run that algorithm, and if other people are running the algorithm, you're going to be exhausting all the cheapest liquidity, and you're probably going to spend a lot of time before your payment gets through. So the adjustment to that algorithm is to say, well, I'm gonna still start with the cheapest, but then I'm gonna start to take the knowledge that I'm getting as I'm making the payments. This node isn't working well for me. This channel isn't working well for me. And I'm gonna start to ignore possible pathways because I think it's just not really worth it to me to try it. This node already returned to me 30 failures. Are they, am I gonna give them the 31st chance? Maybe not. And that's something that you can configure on your own node based on your own time preference. So if you have a high time preference and you want payments to go through quickly, then what you want to do is you want to change the number, the number of times that you're going to trust a node to not fail to be lower. You want to say, like, if this node fails 5 times, I'm going to ignore it for a day. It's just not working. But of course, it might have been that the 31st time did work. So that's not something that you can just say, okay, I'm always going to do it. That there's a perfect settings. It's relative to you on how you want to make payments. And also, this is a two-sided system. So if people are paying more for reliability, that's actually like incentivizing the routing nodes to do a better job. And so that it will become a better choice to pay more because you'll be using the nodes that are responding to that economic incentive. Okay, so a lot of times people are even questioning, like, Lightning itself, is it going to scale? Or like, what are the problems of scaling in Lightning by itself? Like, did we solve scaling? Like, once we release Lightning, like, scaling over, we won? Or, or is there more work to do? And I'm of the opinion that there's still a lot more work to do. And what we achieve with Lightning is we've created a scalable design for one part of the system, which is that we created the HTLC locking mechanism that by itself is not using broadcast. It's not telling everybody about everything and forcing everybody to become in sync. So the larger that it grows, the behavior still remains the same. I'm still forwarding through 6 hops, whether the network is 1,000 people or 10,000 people or 1 million people, 1 billion people. That part is very scalable and doesn't really need so much work. The part that does need work is the graph resources. So part of how Lightning works is, how do I know how to figure out, like, which hops to use when I'm making the payment? And the way that currently works is we have this thing called the channel graph, and every node wants to be a routing node, or maybe they don't want to be, but they just left the default settings. They publish information about their channels to everybody else. And actually, that's using a gossip system, just like the way that the blockchain works. And that system will not scale the same way the blockchain doesn't scale. It doesn't make sense that everybody can tell everybody about everything all the time. So, like, I'm going to update my fees every minute, and you're going to update your fees every minute, and all the millions of people are going to update their fees every minute. We're going to hit a bottleneck there. And then we also need to minimize the bytes that we use on the blockchain. Like, if everybody were making huge channels, or huge block size channels, where they weren't batching, they were using fancy scripts to make the channels, we could make far fewer channels than if we batch channel opens together. And if we do things like swaps to kind of like collapse lots of different liquidity changes together into small amounts of VBytes. And so that's something that we're working on, especially with respect to, like, minimizing the blockchain VBytes. That's something that I work on with Lightning Loop, and we have a lot of possibilities with the Taproot activation to go to huge extremes on how much we can collapse, because Schnorr signature collapse is unlimited. Even if you had 1,000 different people with 1,000 different signatures and public keys, you can collapse all those people into one public key and one signature. So that's something we really want to leverage going forward into next year. So that's kind of my high level of coverage of, like, scaling LND, scaling Lightning. I think we have a couple minutes for questions.
So for the routing nodes, what are the real challenges that is preventing, this is a newbie question, that is preventing running multiple nodes under the single routing node identity?
There's no technical problem to running multiple nodes under the same identity. And it even kind of depends on what you mean by that, because maybe you just mean that the node is the database, and can I run the database on multiple disks or on multiple machines? And that's something that we will have improvement for in LND 0.14 when we add Postgres support, because we can kind of give that problem to Postgres, which is already solved, of how do I run the database on multiple machines. But it's more about building the infrastructure around kind of like, even if I run it on multiple machines, does that mean it's faster? In the first implementation, it won't be faster. What it will mean is it's more reliable. One of them goes down, Postgres will automatically recover, and we don't even have to do anything on the Lightning side for that. We just get that for free because database people already figured that out. Okay. Oh, last question.
Okay. You mentioned one of your early slides about, don't leave your local balance empty. Having tried running Lightning Node myself, sometimes I end up in a situation where it's going to cost me enough satoshis to rebalance that, and based on my experience of what I can charge for routing, it doesn't feel like it's sensible for me to rebalance a channel. So what are my options? I can leave it empty, I can close the channel, I can pay through the nodes to rebalance it. Any thoughts on how a pleb should approach this?
Yeah, that's a good question. So if you run out of balance, one thing I would say is you paid for the information that it's going to run out of balance. Because if you just opened up a bunch of channels with a bunch of different nodes, not all of them would run out. So now you actually didn't lose money. You spent it to get information about money is moving in this direction. And instead of rebalancing, what you can do is add a new channel. You can say, okay, the channel size that I chose in the beginning, it wasn't big enough. I need a bigger one. And then I would use the information to say, the fee was probably incorrect. I was pricing this too cheaply. And so somebody else, I was a low bid for that route. Somebody else used me. And so, I need to open up a bigger channel and I need to charge more for it. But it's also possible that people could be competing below cost. That's something that I faced a lot, especially as an early routing node. People who are, approaching this from an altruistic perspective are actually distorting the market. They're saying, okay, I'll open up a bunch of channels and I'll pay a bunch of fees. And I know of big nodes who have spent multiple, more than a few Bitcoins just on fees, and they never made any money back. And so if you're just trying to be an economic actor competing with them, you have to find places where they're not spending that money. So sometimes you do have to walk away. Okay, thank you.